Good afternoon to everybody. This is Janneke van der Zee from ITS Canada, and welcome to the webinar entitled Truck Platooning, Spreading the Word. I'm handing over the microphone now to your moderator, Mr. Richard Easley. Richard?
Thank you, Janneke. Good morning, good afternoon, from wherever you're calling in from. Participating in this webinar, as Janneke said, truck platooning, spreading the word. And Janneke, can you go to the next slide for me, please? So, a couple of things I want to mention beforehand. First off, most of us know this. If not, then you will be finding out, and if you open your eyes, you'll see all around you that freight innovations are taking place all around us. With respect to the TRB Intermodal Freight Transport Committee, there's certainly research areas abound with respect to just a couple examples you see on the slide. Smart city. How does freight navigate in smart city type environments? Multimodal communities where we have more pedestrian-friendly cities and bicycles are used more often with dedicated. And we also have, of course, light rail that's springing up more and more, and the bicycle lanes, light rails, quite often are where freight deliveries take place in the middle of a freight zone, so that makes it tough for a truck to find a place to deliver. Driverless vehicles, we're seeing an arm vehicles impact freight movement. Sustainability, that's something that affects all of us in transportation. Environmental consciousness, also all of us in transportation, including freight, and there's a bunch more. But giving presentations on freight innovations, one of the things that I found as chair of the Intermodal Freight Transport Committee is that many of the people in the audience have never heard of truck platooning. And so as a committee, and we have a really good intermodal membership, we decided we need to do some educating on folks well beyond just the freight folks. As you all know, we all share the road, and we all share the infrastructure. So we decided that we need to do some webinars, and one of those is going to be on truck platooning. And our thought was, in order to guide this particular type of freight transport, you've got to understand it first. When I say guide, I mean we're talking infrastructure folks, whether you're a highway design, traffic engineer, whatever it may be, even though you may not think you have anything to do with freight. It's coming, and truck platooning is part of that, and you need to understand it before you can make decisions based on it. Jake, next slide, please, Janneke. Today, as you can see here, the moderators are myself and Janneke with ITS. Janneke is also a member of the Intermodal Freight Transport Committee. And our speakers, and by the way, so each of you know, go to the yellow pages, we have some really good speakers for you. Daniel Kretschmer from Cambridge Systematics will kick us off, and then we'll have Professor Humayun Najaran, who has an amazing background in this particular area. And then to batting cleanup will be Steve Boyd with Peloton. Steve, I met Steve a while back, and I am super impressed with him, and I'm sure you will be after you hear his presentation as well. And following all this, we will end answers questions for the presenters, and you'll have in your box over on your screen place where you can actually put the questions in, and we'll answer those at that point. Next slide, please. The scope of this committee includes all aspects of research pertaining to intermodal freight, and more about the committee. Continues to sponsor a private sector applicability award, and that's something that's rather unusual, I think, in TRB, in that not only do we do research and submit papers that are presented at the annual meeting, the best ones that we feel like are applicable to industry, we give them an award, and we have industry actually critique those, and then come to our committee and explain how this will help their everyday practice of moving freight. So that's something that's really a good thing. And with respect to these webinars, we're going to do more and more of these as a committee. Now, we're partnering with, and it's co-sponsored by ITS Canada, but in the future, we're going to do these things, and we would like for you to consider, if you're not already a member of TRB, to become a member of TRB. And as soon as you do, become a friend of this committee, AT045, Intermodal Freight Transport, and all of these webinars will be free to you as a friend of this. So we're planning to do that as a committee function in the future. Next slide, please. Now we go to a word from our sponsors. Recognize if you're not paying for this webinar, sometimes do. But when you don't sometimes pay for things, you have to hear advertisements. We're going to go quickly through the advertisements. And with respect to National Academy of Sciences, TRB, I wanted to tell you a couple things. TRB program unit of the National Academy of Sciences, Engineering, and Medicine. Cool. Now, what you didn't know, a bit of trivia that I found fascinating, I just learned. In order to meet the government's urgent need for an independent advisor on matters, President Lincoln, as in, yes, Abraham Lincoln, signed a congressional forming the National Academy of Sciences in 1863 to, and I quote, investigate, examine, experiment, and report upon any subject of science. Next slide, please. So we've got quite a history here at TRB. Managing research. Go back one more, please. Managing research, delivering policy analysis and advice, providing tools for researchers and practitioners. Some say that TRB sometimes gets a little deep into research, which is great on theory, but practice is a different thing. So we're pulling those together. Next slide, please. More than 500 committees, more than 7,000 committee and panel members, approximately 90+ million budget, and the TRB publications per year. Next slide, please. 250 standing committees, almost every transportation mode topic. Now, those of you that have been to the TRB annual meeting, you know what I'm talking about. And those that haven't, you are in for a treat, and I suggest you go. Probably the best value for transportation of in-conference, and I've been to a lot of them for the dollar. Especially conferences, workshop, and symposia, and those pictures on the right, those are actually from our committee, not just TRB in general, but our Intermodal Freight Transport. Next slide, Ian, the last one for me. Speaking of the annual meeting, more than 12,000 transportation professionals. If you haven't gone, it is mind-blowing to go. Program covers all transportation modes, more than 5,000 presentations, and that doesn't include the committee meetings. Everything from admixtures to runway asphalt to driverless vehicles, and everything in between. Number of sessions and workshops focus on the spotlight theme for this coming year, transportation innovation, leading the way in an era of rapid change. That's quite appropriate, especially with this webinar and the innovations that we're seeing. Next slide, please. Now, what I'd like to do is introduce our co-sponsor, which is ITS Canada, and Chris Philp is online. He's the chairman and CEO of ITS Canada. And let me thank you personally, Chris and Yannicka, for allowing us the ability to use this platform, which is owned by ITS Canada, so that we can all participate in this webinar. So with that, I'll turn it over to you, Chris.
I have been unable to see Chris on the attendee list, so this is Yannicka speaking. So I will do it on his behalf. Thank you all for joining. I'm going to tell a little bit about ITS Canada. ITS Canada is to be the national organization recognized as the thought leader in transportation innovation, as well as being an important contributor to the discussion of transportation issues in Canada. ITS Canada provides a forum for the exchange of information and ideas in the transportation industry, marketing and alliance opportunity for its members in Canada and abroad, industry positions, advice on important societal issues, training in ITS architectures and applications, conferences and regional meetings, webinars, technology showcases and workshops for industry, government, and public. Examples are today's webinar on truck platooning, Spread the Word, an upcoming technology fair this winter, a regional workshop to take place in February of 2017, and the hosting or co-hosting of the 24th ITS World Congress in Montreal taking place next year, October 2017, and positive contributions to the future of transportation in Canada. Over to you, Richard.
Okay, thank you very much, Yannicka. Now let's get to the meat of this webinar. And the first person, and I don't mean Daniel to consider you meat or anything, but the first speaker today will be Daniel Kretschmer with Cambridge Systematics. Real quickly about Daniel, he's 40 years experience in transportation planning, specialized in ITS for the past 23. Focuses on ITS planning and operations for state, regional, local agencies. Let's see. He recently for a major US DOT study of the impacts of connected and automated vehicle technology, appropriate for our speaker, and on transportation plans, currently leading a project focused on the impacts of that technology on ITS and operation. He served as key technical staff on the Gateway Cities Freight ITS project, which we're going to hear more about, which is designed to reduce freight congestion while mitigating the local impacts of truck traffic in the areas reports of Los Angeles and Long Beach. PhD from University of Michigan and a master's in city planning from Harvard University. With that, Daniel, I will turn it over to you. Thank you.
Thank you, Richard, and thanks everybody for attending today. I'm going to talk about two aspects of a very broad program called partial automation for truck platooning, potential application on I-710. I-710 is one piece of this that I'll talk about. Is a survey of truckers in the of the trucking industry in the LA Long Beach region. But to get some idea of the entire scope of this project, which is being sponsored by Federal Highway, managed by the California Department of Transportation, and led by the UC Berkeley PATH program, we are supporting along with Volvo for the project. So the objectives of the project are to explore driver preferences related to cooperative cruise control, and we'll be using that term throughout here, but it does relate to platooning, as you'll see. The project involves an evaluation of energy savings for different headways using both field tests and modeling, estimating CACC capacity, energy, and emissions benefits. As I mentioned, what demonstrates that will be going on with this project, and what I'll talk about at the end is looking toward the future of deployment on the possible I-710 dedicated truck lanes in the Los Angeles area. That's one of the reasons Caltrans is excited about this, and we'll talk a bit about the reasons for that as we move through here. Just a quick summary. A platoon is a series of trucks following each other on the road with acceleration and braking controlled automatically. Please note that in the applications we're going to talk about, steering is still manual. When any truck speed changes, the others behind it are instantly notified wirelessly, and those trucks respond immediately by braking braking or accelerating. The benefits, which we'll talk about in a little bit more detail, allow for closer following distances, reduce wind resistance, and thus increasing the number of trucks that can fit on the road at high speeds, and providing really unprecedented increases in roadway capacity for trucks. Highlighting some of the benefits of truck platooning, cost savings due to reduced fuel usage can average up to 10% on average. Safety benefits, platooning reduces brake wear and better controls following. And based on international testing in Europe, emissions reductions of between 10 and 20% can be expected. Trucking capacity increases on dedicated truck freeways would be a long-term benefit of significance. If you can imagine increasing the number of trucks on a given freeway by 50%, while also improving safety, thereby reducing incident delays and reducing emissions as well. That's just a brief overview of some of the technical definition and benefits of platooning. You'll hear a lot more about the technical operation of platooning from some of our subsequent speakers. I'm going to speak briefly about a truck survey that was taken to get some sense of selling points that can be provided to the trucking industry to adopt this technology, and barriers that might be there as well. Online and printed surveys were used to conduct this survey, and the audience was a group that we've worked with on several projects. Members of the Harbor Trucking Association, a diverse group that primarily serves the ports of Long Beach and Los Angeles, and primarily nearby warehouse districts in Los Angeles and in the San Bernardino Riverside area. 17 respondents were involved in the survey. Most of them were fleet managers, as you can see. So it is a small sample, but I think provided some insight into the views of this technology from the trucking industry. Several of the respondents did indicate having experience using adaptive cruise control, and about the same number reported that they'd never heard of it. The remaining portion of the respondents indicated that they'd heard of the technology or seen it, but had never used it. The general desired period of payback, break-even time for implementing the system was fairly short for most respondents, averaging about 8 months from most of the fleet managers, ranging from probably an unrealistic period of time of a couple of months up to a year. So in general, people are looking for a fairly quick payback on an investment. Platooning is going to be more effective for general operation of the roadways if people are willing to platoon with a variety of operators other than just their own company. So this question went to that. Only one respondent indicated a complete unwillingness to platoon with other drivers. All other respondents selected at least one option, with a split between those who would only form platoons with their own fleet, clearly a limiting factor. Some indicated they would form trucks with specific, perhaps had an agreement with or worked with, and others indicated they would be willing to platoon with anyone out on the road who had similar technology and could be identified as having such. Another key issue is whether operators would be willing to delay their departure time to facilitate platooning. Clearly, there's a trade-off between the benefits and savings that might accrue from platooning and lost time, which might be required to actually form a platoon and obtain those benefits. So again, somewhat of a split with somewhat of a majority indicating that they would have issues with delays if they were needed in order to form a platoon. So this again may indicate there's sort of an adoption curve here that may be slow at first, but then be able to move up as more vehicles have the technology. Respondents were asked how likely they thought drivers would be to use the platooning technology. Again, you can see the split here, the majority seeing a likelihood that drivers would be willing to use it. And in summary, a little over half, key points here were a little over half the respondents did indicate a willingness to use it. Those kind of correlated with respondents who saw the benefits in it, as you would expect. There's a willingness to platoon with either pre-established or known fleets, less willingness to platoon randomly, and again, as we indicated before, a majority indicated a 1-year time frame was what they were looking for payback, 1 year or less. In terms of the program's testing, this is not the first demonstration of the technology. The key element of the demonstration is that testing will be conducted in real-world normal traffic environments. And as I mentioned before, the acceleration and braking are wirelessly coordinated among 3 trucks in a platoon formation. I also need to mention there's a companion truck platooning test to this effort being sponsored by Federal Highway on the East Coast, including Auburn University, Peterbilt, Peloton, who you'll hear from today, and the American Trucking Research Institute, ATRI. I'm going to not talk, as I mentioned, not talk about the test program today. You will hear about testing later. Talk briefly about the I-710 freight corridor fundamental concept. This came up 3 or 4 years ago. Planning has been going on for a long time to expand the capacity and the operation of the I-710 corridor, which serves the main artery serving the ports of Los Angeles and Long Beach. It's an older freeway, 8 lanes, heavily congested with large volumes of truck traffic. And one of the proposals is for a 4-lane freight corridor parallel to the I-710 freeway, a complicated project given the limitations on the right-of-way, but one that's been undergoing design for a while. An interesting aspect of this is that even with an expansion of the general purpose lanes, possibly being able to add 1 more lane there, and the 4-lane truck-only highway, the projections of increased traffic out of the ports are such that even this, under current operating conditions, would not serve the demand 15, 20 years out. So in looking at this option, platooning became a necessity to accommodate the projected increases in container traffic, which have been projected to double or even more by 2035. So just a brief summary of some of the aspects of what would need to be built in to this option. Cars would be prohibited. They would have to use the existing freeway, trucks only on the elevated portion. There would be accommodations built in for vehicle to infrastructure communication, and truck platooning, obviously, as I mentioned, would be the key to operation here. There are a number of other issues as you go forward in the future? Do you want to limit it to platoon trucks and require that they demonstrate certain equipment for coming onto the highway? Again, something out in the future. Brief description of the route is that truck-only lanes would run parallel to the existing freeway. The alignment would vary by location. I'll show you an example in a minute. The maximum corridor length considered is about 16 miles, and there would be 9 corridor connections to and from local streets, given that there's quite a bit of warehousing activity along this corridor. A lot of the trips from the port are fairly short and need access to the local street network and adjacent warehousing industrial areas. So briefly, this is just a map of the corridor. For those of you who may be familiar with the area, running north from the ports up to basically to the I-5 main east I-5 east-west freeway, or east-west portion of I-5, which runs down toward Orange County and San Diego. Just an example of how complicated this all is. Looking at some of the freight connections at one of the interchanges, actually a double interchange along the corridor. And here is a cross section. As mentioned before, there are a couple different alignments. There's a split alignment and parallel alignments, and then an elevated section over, in this case, over the northbound lanes. Some idea of what the configuration would look like here. And again, some idea of the constraints here with the LA River on one side and pretty dense developed areas on the other side of the highway. So that concludes the presentation. Again, in summary, this is probably an advance notice of some projects you might be seeing in the future as planners and designers look at accommodating operation of truck platoons through both construction strategies and operational strategies. These are the key contacts. Mark Jensen from our firm is our key person on this project, and Matt Hansen of Caltrans is the project manager. So thank you for your attention, and if people have questions later, I'll do my best to address them.
Okay, thanks very much, Daniel. Actually, there are some good questions that have come up, and I'd encourage you to write your questions down on the forum. We will get to those. Some really good questions come up, but we'll get to those in just a wee bit. I want to introduce our second speaker, and that's Dr. Humayun Najaran, professor at the University of British Columbia. Humayun is a professor at the School of Engineering, University of British Columbia, received his PhD from Department of Mechanical and Industrial Engineering, University of Toronto. Worked as a research officer at the National Research Council in Canada, where his research focused on development of robotic systems. Appropriately joined UBC and founded the UBC Advanced Control Intelligence Systems Lab in 2006. His research focuses on the analysis and design of mechatronics and mechatronics. Sure, sounds like something from Transformers, but that's good. Mechatronics and control systems with broad applications ranging from autonomous vehicles, robotics, and micro electromechanical systems. Thank you. Dr. Najaran is a professional engineer and president of the Advanced Engineering Solutions Incorporated that provides design and technical consulting service to the automation industry. So this is not brand new stuff for you. This is not your Dr. Najaran. With that, I will turn it over to you. Take it away.
Thank you very much, Richard, for the introduction. And I would like to also thank the audience to spending time to listen to this webinar. So I'll be talking about platooning, and I was hearing from the previous speaker, my friend Daniel, that platooning is a little bit of less heard of word, but probably these days you hear about autonomous driving and driverless cars more often, so I try to relate platooning to that more famous word. So today I'm talking to you from Kelowna in British Columbia, that is housed to the Okanagan campus of the University of British Columbia. And to be more specific, I am right now sitting behind this window in this piece of paradise. So I was reading this book about autonomous driving, and there was a very interesting statement in that book about the fact that we used to have autonomous driving some 120 years ago. And then with the invention of automobiles, we just lost that privilege. And the author was in fact referring to this kind of environment where horses carried our carriages, and there was no issues, and they went around very fast and with no collision. Even pedestrians walk around, and everything was fine. Then with the introduction of automobiles, then we as drivers, we had to take control of car and tell it what to do. So the reason that horses could do that, and we can do, because we share pretty much the same navigation process in doing the job right. And so basically, we use our sense organs, like our eyes and our ears, and animals use the whiskers, the radars to detect the environment. And then based on what we sense, we plan an action to move forward, backward, left, or right. And based on what we have planned, then we get into action. And then every time that we move a little bit, we take that action, we change the environment relative to us. Therefore, we have to go and sense it again. So it's a recursive loop that we have to repeat it again and again to stay on the right track. So autonomous driving or autonomous vehicles is nothing different. They have to do pretty much the same. But I have to also throw two more processes here highlighted with red outline. Two other pieces of processes that is happening on the back of your mind, and you probably don't even pay attention to that. One is that after we sense the environment, which we call it perception, we have to map the environment, generate a 3D map, and then we have to locate ourselves in that map. If you want to just do an experiment with me, see what you're doing. So look around, then close your eyes. You almost know where you are, and you can take a couple of steps without hitting anything. That means you have already built a map of the environment in your mind. So after we have the map, then we create a path, and then it comes with decision making. Typically, you have a couple of different paths to take. So it's, and then you make an intelligent decision on which path is safer, which one is easier, which one is shorter, and then you choose one of them, and then you take your action. So in the case of the autonomous vehicle, then the vehicle control system is responsible to carry out that task. Again, a car moves a little bit, the environment changes relative to the car, so you have to repeat the process. So now to have an autonomous vehicle, as you can see, for example, in this Uber car, you have about 400 different sensors and a hefty computational center in the trunk. So as you can see, it's not an easy process. So that's why the price of the equipping this car with sensors is almost an order of magnitude pricier than the vehicle itself. So to add to that and make this a little bit even more complicated, but more reliable and safer, nowadays people are talking about the concept of cooperative driving. That is the combination of the autonomous vehicle with the connected vehicle technology, which is basically a wireless network based on Wi-Fi protocols, but modified and is called now dedicated short-range communication. And through the connected vehicle technology, you can add the pieces of information and help the autonomous navigation process in almost every step. For example, you can add the sensor information coming from other vehicles as well as infrastructure to the process to help with the localization and mapping. Or you can just offline maps, say, for example, built by a Google map or here, and feed that into the process to help with the path planning. Or after path planning, you can add information from the infrastructure or from other vehicles to introduce additional information about safe path for decision-making step. And then finally, you can add, for example, through connected vehicle technology, road condition and weather condition and help your control system to have a better handle of the driving scenario. So as you can see, this is a very complicated task, and there are probably researchers in robotics, in automation, mechatronics, working with automotive industry for almost 30 years to make this happen, and still the solution is not complete. So, but instead of having the entire process and having a fully developed autonomous vehicle, automotive industry has decided to introduce this at different levels. That's why now everybody almost agrees in the industry that we can have different levels of autonomy, starting from level 0, which means that there is no autonomy, the driver is in full charge, and he's responsible for everything that may or may not happen. And on the other extreme, there's level 5 on autonomy, means it's driverless car. Driver is not there or is not even involved, and obviously the responsibility of a good driving is going to be entirely on the vehicle's shoulder. So as you can see in this case, it's not even the fault of the autonomous car, it's the fault of another driver, but still we hold in the news the autonomous car responsible for this accident. So what does it mean for automotive industry? Is they have to have a completely and absolutely safe solution for their autonomous cars. It has to be the most stable system, and obviously this requires a lot of intelligence for the vehicle. And that means the car is going to be very, very expensive. So that is probably not affordable for anybody these days, but what is available and what is affordable for at least people who can afford buying a luxury car is the highly automated vehicle concept, or HAV. So highly automated vehicle is basically equipped with many features of advanced driver assistance systems. And the advanced driver assistance systems is typically in two different categories. One is just passive warning systems to tell the driver what is in front of it. For example, blind spot and lane departure warning systems, which are nowadays quite common in at least luxury cars, is one. Drowsiness alerts for the drivers, collision avoidance warning are other examples. But there are also active driver assistance systems in a car. That, for example, we heard from the previous speaker, adaptive cruise control, lane change assistance, emergency braking, automatic parking systems. These are additional highly automated vehicle features that you can find in vehicles. Obviously, these are very expensive for a personal car. But imagine that these prices are not scalable. That means that for big or small cars, for cheap or expensive cars, these are going to be the same price. So it is quite reasonable if we assume that implementing this on commercial cars, trucks, and buses is going to be quite affordable and relatively much more economic. So that brings us to the topic of platooning. So I would say that is a very natural way of implementation of HAV in the at large. So now you have this highly automated vehicle features that is affordable for a truck, and all you have to do is to add inter-vehicle communication, which comes, for example, with DSRC again and IR sensors and so forth. So now if the trucks can communicate and they are highly automated vehicles, the platooning is not a far-reaching goal. So just showing a little bit of a history, platooning is not a new concept. Everybody realized that platooning can save fuel, lower emission, and of course improve the traffic flow. That is time and space, as again our previous speaker addressed that very nicely. So because of these all these advantages, back in almost half a century ago in Europe, in a project named Aramis, people started, Volkswagen basically, to start testing this on test tracks without bringing them to public roads. And then Prometheus in 80s and early 90s was a very successful demonstration of platooning, truck platooning on public roads. One of the interesting projects was also in Europe between 2010 to 2012. And in this project, Sartre, was when they decided to combine the fleet of trucks with just personal cars. And an interesting topic was that if I want to join a platooning as a personal vehicle driver, I have to subscribe to that platoon, and then I have to pay for the leader of the platoon who is actually doing the job and is taking the difficulty here. So that would be, in my opinion, a good way or model of encouraging people to do platooning. And more recently is the Platooning Challenge 2016, which I'll explain because of its interesting aspect in the next slide. In US, closer to home, we've had also interesting and successful demonstration. As again, Daniel mentioned, we had PATH in California that started in mid-80s, and it's been very in at least presenting the concepts. And more recently, we have the US Department of Transportation DATP project, which stands for Driver Assistive Truck Platooning. It started in 2013, and they've had quite a few interesting and successful demonstrations. Now, in Canada, unfortunately, I couldn't find any publicly advertised demonstration on public roads, but there is a very interesting and comprehensive study done by National Research Council, my previous employer, with Transport Canada, which was published in 2013, and I encourage you to go to this link and see that report. It was very interesting and comprehensive reports on all aspects of platooning. So in Europe, as I said, this 2016 Platooning Challenge was very interesting public platooning demonstration. And their motto was learn by doing, which I think it has to be the goal for us living in the North America, that if we really want to have autonomous driving implemented for all its beauties and all its advantages, we have to start by trying and not be afraid of taking that technology in. So anyway, in this April 6, 2016 demonstration, 6 giant truck manufacturers started from 6 different cities in Europe, and they all approached Rotterdam in their platoons. And the hardest probably or longest path was for Scania, starting from Stockholm and drove 2 borders and passed 4 borders with no problem. So that brings us to my last slides. I use this opportunity to at least the opportunities I, as a researcher in this field, and see, and also some challenges that we will be facing probably in the implementation of platooning. The opportunity that platooning will offer to, say, autonomous driving in general is going to be that with the implementation on HAV on trucks, there is going to be economic benefit coming out of this widespread use of HAVs. That can eventually, the money generated by this can help research in the autonomous vehicle research, and also it increases awareness and probably start adjusting some of the regulations in this area in transportation. And the other one is that with the expansion of the interconnected vehicle network, which is basically the vehicle-to-vehicle communication, we can at least take the first step of the more probably challenging connected vehicle technology that also have vehicle-to-infrastructure aspects to it. So with the spread of this, because of platooning, then we have eventually get to autonomous vehicle that requires connected vehicle technology also. And I think the challenge that I can see in our way is that probably heterogeneity of the platooning is one issue that Daniel also referred to. So currently, all different truck companies or truck manufacturing companies, they work in silo. They do their research and they keep their experiences secret. And obviously, if, for example, Daimler has a platooning system, a Daimler can join that platoon. So that creates probably a little bit less viable and less sustainable mode of transportation, and this may not be as sustainable from a commercial point of view. And the other challenges that platooning will face, one is that it has to be done on public roads, creating, for example, different lane for trucks may defy the purpose, because one of the advantages was that we are going to save space by platooning or the infrastructure. So if we are going to build a new road, then it's probably not justifiable. So now people have a problem driving next to one truck. Now, if you have a convoy of trucks, it's going to be probably much more challenging and less reasonable. The next challenge that I can see is the regulations. Right now, a convoy of trucks is not allowed on our roads. So now coming and adjusting these regulations to adopt this as a best practice is probably a little bit of a long shot. And finally, what I notice in my line of business work in automation, people are typically afraid of automation. Either it's because they think that it's going to replace human being, and the other one is that they may not trust automation and a machine in the beginning. So that culture has to change. We have to start realizing that, in fact, autonomous vehicles, platooning can save lives. And it's not just about removing the driver, but it's more on the helping the driver. So with this, I would like to conclude my presentation. These are the contact information for myself through my consulting company, adventsol.com, or by email to my UBC account. I would be able to take some offline questions, and I'll be online to answer your questions in this webinar. Thank you very much.
Thank you, Humayun. And I already do have some questions that are there for you, so we'll answer those shortly. Right now, we have our cleanup batter, Steve Boyd. Let's see here. Steve is co-founder and vice president of external affairs for Peloton Technology, a Silicon Valley-based connected and automated vehicle technology company that is bringing innovations in safety and efficiency to the freight transportation industry. In this needs market development and public affairs for Peloton. For the last decade, Steve has worked with innovative energy and transportation companies and driven public policy change to accelerate progress in these sectors. Now listen to this. Previously, he served as an assistant press secretary in the White House and producer at the PBS NewsHour show, and held a variety of leadership roles in national political campaigns, federal agencies, and public policy initiatives. Interesting. Steve holds an environmental science degree from Penn State with minors in economics and political science, and studied international business at the University of Manchester in the UK. He co-founded the Economy Network, now merged with the Advanced Energy Economy Association, and is an active member of the industry stakeholder groups, including TRB's ITS committee, which we both share that function, the Society of Automotive Engineers, and ATA Technology and Maintenance Council Automated Driving and Platooning Task Force. With that, I am pleased to present, as I was with our previous two speakers, Steve. Take it away, Steve.
Thank you, Richard. Can you all hear me?
Yes, yeah, yes, we can hear you.
Great, excellent. Well, thank you, Richard, and thanks, Yannicka. Thank you also ITS Canada and the TRB ITS Committee, and also the other distinguished presenters. So at Peloton, we're working very hard to bring out truck platooning related solutions and bring them to market in the very near term here, rolling out in 2017. So what I'll do today is just talk through some of what we're doing, a little bit about the landscape of other kinds of platooning systems and other kinds of platooning modes and approaches, and provide that as an example of what can be done around truck platooning, what we're rolling out, and what other things may lie ahead. So at Peloton, our mission is very much centered on the North Star of safety. So we're focused on preventing crashes. We're also coupling that with saving fuel, bringing efficiency to fleets and to freight transportation. And we do this by connecting trucks and using vehicle automation. All of this is to empower drivers and empower fleets. So worldwide, we've seen a massive growth in the whole space around truck connectivity and automation, accelerating in very much the recent years and in the current year. But it goes back many decades, as was referred to by the other presenters, going back into the early 90s with the PATH program at Berkeley, continues, of course, as was presented earlier here today. And we actually are part of that project with PATH and Caltrans and Volvo, along with another federal highways project I'll mention later. And across the globe, we've seen everything from the more recent EU platooning challenge that ended April 6th in Port Rotterdam, and continued activity there with the companion project. And the six European OEMs in trucking have been delivering platooning solutions of one kind or another on a research basis for a number of years, and are continuing to show further results with those systems today. There's been work in Japan and Canada, specifically a lot of work in Sweden and Germany as part of the work in the EU with those OEMs in those countries, Volvo and Daimler, Scania, and others doing quite a bit. So we're building a Peloton on global progress in this area, on work that our chief scientist, Chris Gerdes, did at the PATH program at Berkeley and in his own work, then later at Stanford. And Chris Gerdes was has been the longtime leader of the Center for Automotive Research at Stanford, and is now on leave of absence from Peloton and Stanford to be an advisor to the US DOT, the first ever Chief Innovation Officer at US DOT. And he finishes up that term of service early next year. But the work, anyway, that we're doing is built upon many decades of progress that's been occurring, some of which was referred to earlier, and that we're building on with new solutions and new technologies here in our company based in Silicon Valley. So our team consists of an array of folks with decades of experience in automotive and truck industry, in cloud and software, in enterprise sales and business development, and in government, media, and advanced design. Our team includes a wide and growing array. This picture is from many months ago. We're now double that and growing, folks from a lot of different experience across both Silicon Valley and other parts of the automotive industry. Our board of directors includes Rodney Slater, former Secretary of Transportation, a number of other leaders, including Larry Burns, who was just added to our board about a week ago. Larry, the longtime VP of R&D at General Motors, and an even longer time visionary on vehicle automation, vehicle safety, and advanced mobility. We have a number of advisors across the whole sector as well. We have a number of strategic investors, including 8 Fortune Global 500 companies. These are financial investors. There's not special exclusivity deals with them on rolling out platooning, but they include a number of companies from Volvo to UPS, suppliers like Denso and Magna, technology and energy companies like Intel, Nokia, Lockheed Martin, British Petroleum, and a number of other investors in the technology sector here in the Valley. So we work by making trucks safer on their own all the time. We start with that. We improve the individual truck safety by building upon state-of-the-art active safety systems, collision mitigation, blind spot detection, lane departure warning, and other existing tools. But we bring forward the best that are available today, and are working actively with the major North American suppliers of these systems, Bendix and Meritor Wabco, to integrate our solutions with theirs and add to their solutions additional contextual information. So over-the-horizon information, cloud-based inputs that improve the awareness of that system on the trucks and make it contextually more effective to be providing safety to the truck and information to the driver. So we provide the improved visibility and over-the-horizon alerts to the drivers, state-of-the-art active safety systems, integrated safety monitoring and event capture, and enhanced predictive maintenance, among other things. This done again with vehicle-to-cloud connectivity, and then for that individual truck that's safer all the time, we then use the vehicle-to-cloud monitoring to improve how we bring trucks together and coordinate them for platooning, specifying their order intelligently so that the heavier, longer stopping distance truck is always in front, making sure that they're at an appropriate following distance for the profile of those trucks and their braking ability, the conditions they're in, and the roadway that they're on. Our system is 2-truck platooning, just 2. Drivers are fully engaged at all times, steering at all times, So it's level 1 automation, no more than level 1. Drivers are always engaged. And our vehicle-to-vehicle communications link provides a reduction in the response time of braking down to the tenths and hundredths of a second. This allows us to bring the trucks closer together, and that's the core of course, platooning systems in the advanced form, is using vehicle-to-vehicle communication, since using ACC alone does not provide rapid enough response time for closer following. So with our cloud-based monitoring, we're continuously determining where it's appropriate for platooning to occur. Should the platooning continue, how are conditions changing to affect that? And so platooning is only occurring where it's safe, where, when, and how it's safe. On multi-lane divided, limited access highways, under appropriate traffic, weather, and road conditions, and observant to construction zones, work zones, other changes that are occurring ahead on the roadway that allow us to warn trucks and drivers and separate them and change their mode well in advance of entering any kind of changed area. A key part of what we do to help the drivers and improve their awareness when they're in platoon is shared video between the trucks. So the rear truck has a view of the road ahead. The rear driver sees the road ahead from the view of the front driver, and the front driver sees his or her blind spots from the view behind. Now we want to kind of look at the levels of automation that we're all operating in here today as we explore various levels of automation and various kinds of systems. We know that increasingly in passenger cars and in demonstration systems in trucking, there are higher automation systems emerging at level 2 and up. And one challenge area that we've all seen and been observing is when drivers assume a system has more automation and more capability than it. So that someone may be driving a Tesla and think it's got level 3 automation when it's really just level 2. And mode confusion and capability confusion is a central problem to all of this. And we tackle that by making it very clear to our drivers and the way the system operates with their input, that they're continuously engaged. There is no detaching from the function of driving as part of this level 1 driver-assisted truck platooning. Now, of course, other solution providers in the passenger car space are rolling out and testing now level 5 fully automated. Most of this is occurring at lower speed in the sort of direction of robo-taxi type solutions in lower speed environments. And there's more beyond that, of course. For today, we're focusing on platooning, level 1, driver-assisted platooning. And so our systems are at level 1 with simply longitudinal control in the case of our system, not lateral control. So this means that the front driver in our system is always hands-on and feet-on. They may be using the adaptive cruise control and collision mitigation always in the front of their truck, so they may be in a cruise mode with active safety. That is the preferred mode, but the driver is fully in charge of that vehicle at all times, as is the rear driver. The rear driver, though, in a cooperative adaptive cruise control mode. And this system has similarities to the past project platooning system that was talked about before, which is that being a 3-truck solution that Volvo has put forward working with PASS. Rear driver in our solution, hands-on, in a adaptive cruise collision mitigation cruise mode, connected with the front truck. But again, both drivers fully engaged, eyes and brain on the road, eyes and brain fully engaged in the driving task. Now we're using our cloud-based system then to improve a variety of aggregation of data, bringing together key data to assist the drivers, the fleets, and to provide the benefits to other stakeholders. So we're bringing in data from various sources, here in shorthand called internet data, but data from all manner of sources, from state sources and other sources about traffic, other state-of-the-art solutions, partners we're working with to bring the best together on granular data about traffic, weather, work zones, and other information, vehicle data coming off the individual vehicles and other vehicles in the network, and then the sensors on the vehicles, which provide deeper sense of the environment than current present-day telematic systems. With this data, we're able to provide new solutions that alert drivers and provide performance coaching to drivers, safety approvals, and the platoon ordering, platoon management we talked about. But the core of it's around the platoon functionality, then with also advanced safety and other benefits to fleet. Fleet managers get benefits around advanced analytics, predictive maintenance, and other kinds of diagnostics. Highway operators can get aggregated, anonymized data about the roadway, this in partnership with fleets to improve the knowledge for all motorists and the highway operators. So massive amounts of useful data properly delivered at the right time, and this gathering of data also helps us build the knowledge base for our fleet partners and others to advance what they're doing with truck operations, advance what they're doing around improving the safety of these vehicles and the capabilities of these systems. We provide a variety of dashboarding for fleets to make use of, and as part of both monitoring and managing the use of platooning, and to understand how to optimize the return of the systems and the safety and effectiveness of their drivers and the efficiency of their freight operations. The core of the economics here are based on the fuel economy benefits, which are on the order of 10% for a rear truck, 4.5% for a front truck, as independently verified by a number of entities, Department of Energy, US DOT, North American Council on Freight Efficiency. An example of a robust set of testing was showing the 10% and 4.5% results at a 40-foot gap at 65 miles per hour. We've done a full other tests with multiple independent evaluators at varying speeds and following distances with robust benefits at gaps, following distance gaps of 75 feet or more for both vehicles. The rear truck, of course, benefits for a longer period of time, a longer framework of distance between the vehicles. Our core rollout of platooning starts with focusing on platooning within the same fleet so that pairs of trucks and that fleet benefit equally. The fleet benefits because the front truck and the rear truck are in the same fleet. In future deployment past the initial work with major fleets can interoperate, and then differential pricing is provided to front truck versus rear truck to allow for the ordering of trucks and for different fleets to participate in platooning. This is a list of kind of a wider set of truck benefits beyond the core aerodynamic efficiency benefits, ranging from not just the fuel savings, but the crash reduction benefits. In order to have the safety systems, in order to have the platooning capability, you must have the advanced safety systems. These advanced safety systems, shown by extensive studies, bring down accident rates dramatically, crash rates dramatically, with 80% reduction in rear-end crashes, based on studies by NTSB and an analysis of just the economic savings several years ago by NHTSA showed that just deployment of at the time current safety systems would provide over $3.1 billion in annual savings in the U.S. And it goes beyond that. Fleets like Conway, by fully deploying active safety, have seen crash reduction rates of 86% or better. Along with the fuel economy benefits, you also have the greenhouse gas and criteria pollutant emissions reductions. There's the high quality data generation for fleets and governments that we've talked about, and also the benefits around improved infrastructure efficiency and mobility, which some of the other presenters talked about. The way we're rolling out platooning allows for under 1 year payback period for higher mileage trucks, typical mileage trucks of about 100,000 miles per year. Those numbers stay very strong for your typical line haul trucks with an under 1 year payback. And then wanted to talk a little bit about the various kinds of platooning systems that we're seeing emerge both in the near commercial systems and in research. So around the number of trucks, we're using a 2-truck approach, as have some of the EU Truck Platooning Challenge representative trucks. So the Euro truck manufacturers, those truck systems, their platooning systems have been showing 2- and 3-truck combinations. The near commercial systems seem to be focusing on 2-truck solutions for regulatory, public acceptance, and other reasons. Also for logistical matching within fleets to get infiltrations of trucks together for platooning. Two trucks is trending towards being the way to roll initially. There'll be certain use cases where longer combinations of vehicles are possible at the 3-truck level, like Volvo and Path are showing. Use environments are on highway. There are then urban and low-speed environment opportunities using the same sensors, other functionalities around the vehicle, the infrastructure opportunities using the DSRC V2V connection, and then those same connectivity for use with communication with infrastructure. And the new commercial systems like ours are at level 1, in our case, longitudinal control, and no or limited infrastructure requirements in the way of new infrastructure. So while dedicated lanes are being looked at for special cases around, say, congested port areas like the I-710 corridor that was talked about before, this is not necessary for platooning. And then again, vehicle infrastructure is useful but not necessary in terms of having the present infrastructure. This can all be done with just V2V. With the research systems, we're seeing 3 and 4 truck combinations or more in certain kinds of research programs, and various kinds of use environments as well. Some of these higher automation solutions, of course, then be able to do a variety of things in the lower speed environment around ports and distribution centers. And there's already uses in private on mining facilities or on mine access roads in various parts of the world. And we're working actively at Peloton with fleets on advanced and higher automation approaches to operations inside some of their facilities in another setting. So level 2 and up for these kind of solutions. A variety of folks out there doing the work on a research basis, early development basis, and then obviously we're all working towards finding use cases that can allow appropriate deployment of increasing automation in a way that empowers drivers, empowers the role of freight operators. We see a role for freight operators going forward as we see the effect of the increasing freight volumes that are mostly going to trucking in most parts of the world over the next 5 years, over 25% freight growth, and over 70% of that to go into trucking. This in an environment where there are 50,000 or more of a driver shortage every year and growing, with declining entries into the field and with expected generational retirements. We think that the key thing here is providing the best tools, safety, and information to make each driver more productive and capable, and to help them then work with fleets to take on the growing freight challenge. But there is a lasting and robust role for freight operators in the coming years here, from the perspective that we're taking. In certain of these research systems and in certain use cases around ports where there were already dedicated lanes being planned, there may be value to either smart lanes or other approaches to allow for higher automation or certain kinds of platooning applications. But the approach that we think is most effective is to not be relying on new infrastructure and find other ways to tackle the problem. Certainly where there can be dedicated lanes, it could accelerate deployment of higher automation systems and other solutions. Same so with vehicle infrastructure, providing benefits to higher automation in speeding the deployment of it in certain cases. We're operating in the U.S. in an effort to help tackle the $700 billion industry in revenue, and of course it's larger when you include Canada. We are helping fleets deal with their main pain points. Over 1/3 of their costs focus on fuel costs, and very high order costs around crashes and accidents, and net with an environment where fleets typically have razor-thin profits of 3% or less. And when we add in the Canadian freight market, $65 billion in revenues, and the global market, of course, into the trillions. We're focused on preventing accidents, saving fuel, improving decisions, and enhanced fleet economics and safety for both the industry and the overall public. Because platooning requires, and these systems require the advanced safety systems, it accelerates the deployment of these safety systems into fleets faster than the current market is adopting them. And this makes each truck safer all the time, individually where it goes. we're excited linkage of safety and efficiency. Today, in terms of dispatching, many trucks and many fleets are already traveling in packs today. So towards the earlier survey data that was showing reluctance to delay trucks to bring them together, fleets already have trucks dispatching very close and with minor changes to dispatch in terms of their existing shipping plans, even more trucks can be put together. These are examples of just some of the fleets that already have many trucks together on hub-to-hub and other routes. We're operating in the 45,000 miles or so of interstate highways in the United States. Similar map, would apply to Canada. And it's on these roadways, multi-lane divided, limited access, that it's the appropriate environment for the highway speed to truck platooning at level 1 automation. We've been working with both federal and state officials across the country, lots of great support and engagement, active efforts by the states and federal government to promote and assist the exploration and development of these kind of solutions. So there's 2 U.S. Department of Transportation projects, one with Caltrans and PATH, partnered with Volvo, one with Auburn, partnered with Peterbilt. Peloton's part of both projects, and we're honored to be involved with those programs and the platooning work that they're doing and other parts of the truck automation that are being explored. We're also partners on one of the Department of Energy SuperTruck 2 programs that's rolling out. We're working with Volvo on their SuperTruck initiative, SuperTruck 2, and we're also a team member on the Smart Columbus US DOT Smart City Challenge. We're also in the running for two programs, 2 projects with ARPA-E under their Next Car project, which, despite the acronym, is focused on commercial vehicles. And in the states, we've held formal demonstration activity with 7 of the states, with more coming, and testing and trial approved in 10 states and rising, high interest from 20 more states. And then state-specific or city-specific projects in key areas, such as a recent California Clean Energy project funded at the Port of San Diego, looking at both urban freight activity, B2I, freight signal priority, and also platooning in regional haul coming out of the port. So that's what we have for today, and really appreciate the opportunity to talk with you all and look forward to the questions. Thanks very much.
Thanks, Steve. Thanks very much. I particularly like and want folks to notice the partnerships and the programs that are going on in the U.S. right now. Not 10 years from now, but right now. There are demonstrations, things taking place right now. At this point, what I'd like to do is open up the questions. So if Yannicka, you could actually turn on the microphone for all 3 of our speakers, I will run through what some of the questions are in order that they came in.
They're unmuted.
See. Okay, good. Let's see here. What we want to do is go to the questions, put it in order they came in. And the first one, my fellow presenters, here's the first question. Are there numbers on the return on investment for truckers? From Rodrigo.
This is Steve Boyd. I can provide an answer.
Please.
So I would just comment that I guess by saying truckers, that could be interpreted as being either individual owner-operators or drivers within a fleet. Certainly for fleets, there's the ROI we're seeing for typical line haul trucks is under 1 year. The solution that Peloton's putting forward, there's a business model that works for operators. The business model works best once an initial set of large fleets deploys truck platooning, and on certain corridors there's the adequate density, which happens pretty rapidly on a key corridor, that independent owner operators could participate in platooning by teaming up with other fleet trucks. And the payback periods and ROI are similar than for an owner operator. We're in active discussions to develop some packages that work well for particularly for independent owner operators. And then for drivers within fleets, most fleets have bonusing or other incentive structures for efficiency, MPG bonuses and other structures that are easily adaptable to benefiting drivers for using platooning. And we're in active discussion with a number of fleets about how those programs will apply to their use of platooning.
Okay. Thanks, Steve. We got a lot of questions. The next question was, how does California Highway Patrol feel about truck platooning in terms of enforcement? All three of you could probably have some comment on that one, but I'll open the floor to any one of you.
Does anyone else want to take that one first? I've got a comment.
Go ahead.
Okay. Yeah. So there's in California we've worked with the various states that I know that we've got 10 states that have approved trials and testing, fleet trials and testing. California has a bill that was passed. It's called SB 719, Senate Bill 719, and this bill has created an authority for truck platooning testing for Caltrans and for Caltrans partners. Peloton is a Caltrans partner, part of the PASS Caltrans project, and as part of that, we fall under that testing approval process, which is a process by which testing parties submit a proposal to CHP for where testing is to occur and the other parameters of that testing. Typically in California, then for certain kinds of off-peak activity is possible on multi-lane divided limited access highways that are approved, where they've approved a testing plan. The falling distances, the preferred falling distances can be at 100 feet when you have a pair of trucks together, since that's interpreted as a caravan. Where there's an existing vehicle code requirement regarding 100-foot distance between caravan vehicles, but under this testing authority, closer falling can be approved as part of an approved plan, and so testing of that kind has been approved for PASS, and similar testing process is underway with CHP for Peloton.
Thanks, Steve. Yeah, I'd heard that, I think from Iwasaki, that there are laws on the books. Basically, the laws as they're written on the books make platooning illegal because of the proximity of the trucks together, but those laws were written before the technology has reached the maturity that it has. So there's this process of going through the change. So thanks very, very much for that. The next one here says, does Otto work on platooning? Anybody care to field that one?
I hate to be monopolizing. I've got an answer, but does anyone else want to talk about it?
Go ahead, Steve.
Okay. Yeah, so, I mean, obviously we all read the news reports about various things going on. A variety of, first of all, I would say that, there are a number of major truck OEMs that are moving along at a good clip on rolling out truck automation systems. These include Daimler with their U.S. company Freightliner, and Volvo itself, one of our partners, and the PACCAR OEMs, Kenworth in the U.S., and Navistar as well. So, for example, Navistar has a truck platooning project underway that's already demonstrated this summer, working with Texas Transportation Institute, and Peloton's also working on integration plans with Navistar. So there's a variety of folks that have demonstrated platooning systems. Daimler did so in Germany with a 3-truck platooning system demonstrated last summer. It actually had higher automation with level 3 automation occurring, at least in the research demonstration, with those 3 trucks in platoon with drivers at level 3. And so there's a variety of folks out there doing work with the combination of higher automation and platooning. Otto has not publicly talked about what they might be doing on platooning. They're mostly in the news, and we know the folks there. they're mostly, indicating focus on individual truck automation solutions with an aim to provide, roll out a use case that could be applied in the future when regulations allow. I think their approach is that they have to keep drivers in the vehicle, and that's what they're doing now. That's what the rules require. Speaking of CHP rules, drivers have to be in there. Drivers have to be driving. So we'll have to see what more comes out of the news about what Auto says they're doing. And I think that we'll be seeing also reports further from folks like Daimler, Freightliner, the other U.S. truck OEMs. And we also have other news that we'll be rolling out along with Volvo and other OEMs.
All right, good. I'm gonna, Ahmad, you're gonna have to forgive me. I'm gonna drop down a few questions because you have a lot of, which is good, and we're gonna be able to work through that with emails to get information to you from the presenters after I run out of time. But I'm gonna drop to this question, you guys, and although this one's for Steve, surprise, surprise. When connectivity to the cloud is lost, is platooning disabled for the vehicles? Also, is platooning being considered for LCVs, doubles and triples up there on the roadway?
So on the cloud question, what we do is we provide a time-limited approval to the vehicles based on where they are. The vehicles navigation and intelligence, and are able to operate effectively without continuous cloud connection. After a certain duration, that's based on what kind of roadway and conditions they are around them and are ahead of them. The platooning approval will drop if it's lost for too long a period for the given roadway and conditions that those trucks are in. But so there's a persistent authorization that varies depending on the situation and the roadway they're in. As far as the other question was about long combination vehicles, I think LCV, multiple trailers. The deployment plans and the fleets we're working with, they're aimed at using truck platooning with single 53-foot trailers and with double pup 28-foot trailers. So the combinations that you typically see in most areas of the U.S. We're not intending to roll out platooning initially with longer combination trailers. We want to start with, and we think it makes sense to work with fleets where they're able to operate with the trailers in most environments across the U.S. highways. There may be some use cases where other kinds of combinations may be possible, but we're taking the approach to use the more standard trailer configurations here at the outset, and we're very much in active dialogue with both federal and state leaders on these kind of topics, as well as the fleets. And our rollout of these systems is being done with only the highest performing large fleets, like the large LCL package carriers and some of the private fleets, as well as the for-hire carriers that have the strongest standards, best safety records, the best drivers.
That makes sense. That makes sense. It's 2:54. We have to the 3. I'm gonna, and folks, you can be mad at me as moderator for jumping around the questions after all, because there's a lot of really good ones, and I know I've got about 20 minutes worth of. I'm going to combine these two questions that I like. One is, and this one's a pretty simple one. This is a softball one. What do you mean by active braking time reduced from 1.5 seconds to of a second? Do you mean the driver response time or something else? That's one question. And the second one is, any thoughts about transporting dangerous materials? From my buddy at Transport Canada for his question. Anybody care to address those two questions?
Yeah, sorry, I was having to move locations here. So on the question about what is the speed of communication between the vehicle-to-vehicle communication system to initiate braking, as opposed to the lag time associated with, I'm going to pull the slide back up here.
Right, from 1.5 down to 0.03 seconds.
Yeah, 1.5 reflects the, actually that's the, relates to the action time for a driver, a human driver. And then the second time is the instantaneous, reflects the near instantaneous link between the vehicle braking systems.
So basically, digitally, the communication is much faster than the processing time of the brain. The communication of the vehicle and the systems on the trucks are much faster. That's why we get that difference in the great reduction in time, which means we can have closer headways. So that's good. The second part of that is any thoughts about transporting dangerous materials?
And the answer there is that no, platooning is not aimed to initially be working with, or transporting hazardous materials with platooning. The approach is to work with more standard fleet operations, and so this is not chemical tankers and other solutions like that, other applications like that.
Understood, Steve. That makes sense at this point. Until we got everything out there, that makes sense. One more thing I wanted to ask you, and at the risk of upsetting everybody on the questions, this is my question, and there's a reason I want to ask this one. You mentioned that there are certain conditions where, and so that makes sense. Now, I'm thinking of a couple of situations. One, I'm going down the highway, fine, we're platooning, then we reach the outskirts of D.C. or Philadelphia or Atlanta, and there's a lot of congestion. I would say probably a good idea to shut it off then. But the other one is relevant for everybody on this call is if I'm going down the highway and we've all hit that construction, we've got a bridge that's being worked on, and we had to divert over into a very narrow lane, over to the other side of the highway, cross the bridge, and then come. You have to slow down, and it's really careful. I'm thinking to know where those construction zones are, those work zones, that information has to be transmitted by the DOT somehow to the folks so that we can get this information to Peloton and the other vendors that are putting these systems together. How does that potentially work, or is that happening now?
So the way we're approaching that now, and the other panelists may have some thoughts about what they're doing within their programs, the way we're handling that now is that we're working with specific DOTs on fleet trials on particular corridors. So in those cases, we have both and in most of these states, they already have updated road construction and road status information that they provide in certain data formats that we're able to tap into and connect with. In addition, though, for the particular trial corridors, we're not only getting the real-time, the latest situation as far as construction that's planned, but also the future planned construction. And we're, as part of the trial activity, whenever we're doing any kind of platooning work or other sorts of truck advanced or safety work, we're sending we're gathering information about that roadway with reconnaissance vehicles first, and then updating that information with equipped vehicles. So in a given truck platooning trial, for example, we have some vehicles that are equipped with all of that and have platooning capability but do not platoon, and they're out there gathering that information about the roadway in real time each day, whereas other of the vehicles are able to platoon and are engaged to platoon when using that information that's available and updated. So we're working with a variety of providers like INRIX and others that are leading the way on bringing together some of this kind of information. We're also using and working to advance additional crowdsourcing about the current state of roads that, as you know, is being done by a variety of different solutions providers that are working with motorists as well.
Great. The reason I asked that, as we shut down here, the reason I asked that is because there may be people on this webinar who think, oh, this is all real and good, it has to do with freight and truck platooning, but I'm highway operations, I don't deal with that, that's Shirley's job down the hallway. Now, what I wanted to illustrate that information has to be delivered in some form or fashion to our freight community, because there usually be some pretty bad situations if that doesn't happen. So I just to wrap, we're all involved in this. It's not just somebody else. Freight is not somebody else's issue. With that, I will say, I want to say thank you to Dan, to Humayun, and Steve for educating us, making us smarter on truck platooning. And I think Yannicka has wants to send out a survey to the folks on the call. And the process for answering the questions that weren't answered on the call, Yannicka, can you help us with that?
Yeah, they will be shared offline with the presenters as we sort them. And I think the only other thing I'm asking of Daniel, Humayun, and Steve, can we hand out your presentations in PDF format to the people who were on the call today?
Yes, as far as I know, that's fine.
Okay.
Yeah, it's fine for me as well.
Okay. Steve?
Yes, that should be fine.
Okay. And there's also a recording of this webinar. So the moment that I hit the stop button, we also will be sharing the recording of this webinar with the attendees. And I think, Richard, you might want to put that on your committee website, and I will put that on ITS Canada's website as well.
Sounds good. With that, I want to tell you all thank you very much for participating, and we'll talk to you soon, hopefully.
Thank you.
Thank you very much.